हेलो प्यारे बच्चों, कैसे आप सब लोग। आई होप यू आर डूइंग ग्रेट एंड प्रिपरेशन अच्छा चल रहा होगा। आज का ये वीडियो कंटिन्यूशन में है लास्ट वीडियो के। वी आर गोइंग टू डिस्कस केमिकल प्रॉपर्टीज ऑफ एल्डिहाइड एंड कीटोन। यू कैन राइट डाउन विद मी। अगर अभी तक चैनल को सब्सक्राइब नहीं किया है तो कर दीजिए। केमिकल प्रॉपर्टीज में जो हम सब्स्टिट्यूशन पार्ट कर रहे थे, सब्स्टिट्यूशन रिएक्शन का पार्ट अपना ऑन है अभी, से पहले की वीडियोस आप चेक कर लीजिए। सब्स्टिट्यूशन में आज हम समझेंगे विद फोर्थ पार्ट है इसका 2,4 डाइनाइट्रो फिनाइल हाइड्राजीन। Okay, we call it Brady's reagent. Brady's reagent. Okay, so the reaction is like that. Very easy reaction. Okay, so you have a ketone plus you have to add 2,4 dinitrophenylhydrazine. That is your hydrazine, so it will be look like that. NH2 NH. Here you have benzene ring. 2,4 means here it is NO2 and 4 it is NO2. So this is your hydrazine. Okay, so whenever the reaction occur, you have to subtract the water molecule. That will be your this. After subtracting this water molecule, you will get the result, that is double bond, and all you have to add NH, NO2, NO2, and it is benzene. So this will be your product plus water molecule will goes out. So this will be your reaction. We call it 2,4 dinitrophenylhydrazones. What is the name of this compound? 2,4 dinitrophenylhydrazones. हाइड्रोजन से क्या बनता है? हाइड्राजोन. You can remember that, or its PPT is orange color or yellow color PPT. So this is very crucial method and we call it substitution reactions. Okay, the next will be the part of second substitution method. It's not related to the NH3 derivatives, ammonia derivatives. We have ammonia derivatives in which we are going to discuss. We already discussed about it: hydroxylamine, hydrazine with semi-carbazide, and the fourth one is phenylhydrazine, and the fifth one is 2,4 dinitrophenylhydrazine. So yeah, now the substitution reaction will go ahead, and the next reaction will be with primary amines. Primary amines. So this reaction is like that. You have aldehyde plus primary amines. Okay, so H2 and R. This is your primary amine. This will give this H will attach here, OH, and this NHR, right? If you have done it, आपको पता होगा shifting होता है negative sign, positive sign, and then this H plus attack here or the other attack on carbon. So after that reaction forward, minus H2O you have to do, minus H2O, and after minus H2O it will look like that. CH double bond will come and R. Okay, this is aldimine. 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 This is called aldimine and also known as Schiff base. RCH double bond and R. You can write down the example, but before that you have to go with the ketone also. So if there is a ketone, this is your ketone with H2 and R. That will give R COH R. यहाँ पे आ जाएगा NHR. After minus H2O, it will give R Cr double bond Nr. Okay. You can write down the example. R could be any alkyl group, and you will get the example. Write down one example of each. R could be any alkyl group. The reaction follows like that, and this is very important. Shift base. Okay. The next reaction substitution goes with third one part, and that is with PCl3. Okay, so you can take aldehyde or ketone, anything, react with PCl3, that will give Cl here and Cl here. For example, you have cyclohexyl methyl ketone. Okay, this is your cyclohexyl methyl ketone reacting with PCl3. The temperature would be 0 degrees Celsius. Okay, so what you have to do, minus PoCl3. After that the reaction will forward, and this will become C, Cl, Cl and CH3. Okay, in this reaction if you add further NaNH2, 3 moles of NaNH2 basically, then what will happen? C triple bond CH. Okay, so this Cl will goes and there will be a triple bond in this reaction, NaNH2. Okay, so we call it let me name it for you. We call it cyclohexyl methyl ketone. Hexyl methyl ketone. Okay, cyclohexyl methyl ketone. Okay, and the next one is a James dichloride. The yield is 70 to 80%. And the next one is cyclohexyl acetylene. Okay, this is acetylene. The next reaction we are going to discuss in it is the third part of the reaction. After addition substitution, we are going to discuss the reduction reactions. This is third part of the reaction. First in addition, the second one is substitution, and the third one is this. So when carbonyl compound on catalytic reduction in the presence of catalyst, okay, catalytic reduction and reduction with complex metal hydrides. So we can take metal hydrides also, you know that NaBH4 and all metal hydrides give alcohol. So यहाँ reduction करने पे हमें क्या मिल जाएगा? Alcohol. Let's go with the example. For example, you have aldehyde. This is your aldehyde in the presence of H2Ni, or you can take Ni की जगह PT, PD, whatever, or you can use LiAlH4, that is strong reducing agent, or you can use NaBH4. ठीक है, तो यहाँ पे complex metal hydride आप use कर सकते हो. That will give RCOH H. Okay, further this is your 2 degree alcohol. You can see 2 degree alcohol. This one is 1 degree alcohol. This is only one R group, so 1 degree alcohol. Okay, you can write down one example of it if you want. Example would be very easy. CH3 CH2 C double bond O H. This is your compound. रिडक्शन करना है आपको H2Ni की प्रेजेंस में, or LiLH4, whatever you want to use. So it will give direct alcohol CH3 CH2 CH2 CH2OH. ओके, 85% ब्यूटेनॉल बनता है इसमें. Let's talk about ketone, how the reaction follows. So suppose we have ketone. Okay, so this is your ketone. When it reacts with H2Ni or LiLH4 or NaBH4, whatever, Ni की जगह आप PT PD कुछ भी ले सकते हो. It will give RCROH, that is 2-degree alcohol in case of ketone. And further, the examples are like that: CH3 C double bond O CH3. This is your ketone. H2Ni, that will give CH3 C OH H CH3. So what is that? 2-butane. No, the yield is 87%. The next reaction is very easy. We called it reduction with alkane. The second reaction in this is reduction with alkane. Reduction with alkane goes like that. Suppose you have a carbonyl compound C double bond O plus. We have to use in this reaction basically Hi or red phosphorus. Okay, so you can use reduction by red phosphorus or Hi. So with जगह इंटू कर लीजिए, हम एल्केन में चेंज करेंगे इसको. So 4Hi, that will reduce this compound in the presence of red phosphorus plus 2I2 plus H2. So this will be your alkane, and you have to remember this products also. I2 is released and the alkane will be formed. Okay, very easy reaction. In the presence of Hi and red phosphorus, it will reduce to alkane. The next reduction will be Clemmensen reduction, very popular, very easy. Clemmensen reduction. In this carbonyl compound, that is your C double bond O compound, reduce it in the presence of zinc amalgam. And concentrated HCl. Okay, so what you have to do, RCHO, this is plus hydrogen in the presence of Z and HgHCl, that will give RCH3, alkane again, and H2. Same reaction follows with ketone also. So the reaction will be like that. Gen and HgHCl, that will give RC. Here it will become H2, okay, plus water. So this is the Clemmensen reduction, very easy to make alkane and very popular also. If you haven't subscribed the channel, subscribe now. We will go ahead in the next video. Thanks for watching. Subscribe now, okay.